Hey guys, in this short video we're just going to work through section 20.4 in lesson 20, and it's on page 309 in your book, and this will just get you some more practice with solving inequalities. Here we go. Okay, I solved 1 as an equation, and you can follow my work there. I got x equals 0. I'm looking here, the only one that has a dot on 0 is f. I just want to double check that this is true, so I'm going to plug in -1 into my original inequality and make sure it makes it true. When I plug in -1 for x, I end up getting -6 is less than or equal to -3, which, yes, is true. So F matches with number 1. When I solved number 2, I got x equals -2 as the boundary, and it looks like E is the only graph with -2 with a dot. So I'm going to test a point that's on that side. I'm going to test 0, plug it in, and see if it works. Okay, here I plugged in 0 for x into the original inequality, and I got 0 is greater than -1/2. And so that does work. And so E matches with number 2. Number 3, when I solved it as an equation, I got x equals 2, and I see that both B and C have dots on 2. So I'm going to plug in 0 to see if this one is true in B or this one is true at C. Here I plugged in 0 for x into the original inequality, and I got 4 is greater than or equal to 0. And that is true. 4 is greater than or equal to 0. And so that means that B, where 0 is in the solutions, that's the one that matches with 3. When this one is solved, we got x equals 1/2 as our boundary. That is showing D that has a dot at 1/2. Let's just test 0. Plug that in and make sure that it does in fact make it true. When I plugged in 0 right here, I did end up with a true statement. -2 is less than 4, and so D matches with number 4. In number 5, when you set it up as an equation, it'll look like this, and the first thing I would do to solve this would be to multiply both sides by 3. So on the left, it's going to be like 3 over 1, because then those 3's cancel out, and you're left with 4x minus 1 over 1, which would just be 4x minus 1 equals, on that side it'll be -3. Here we end up with a boundary of x equals -1/2, so that looks like it's going to match with A. Let's pick something to plug in and just make sure first. 0 is in those solutions, so you could pick 0, you could pick 1, you could pick any of these numbers. Plug one of them in and make sure that it makes it true. I chose 1 to plug in here just to do something different. And when I plugged that in and simplified, I got 1 is greater than -1. And so, yep, that is a true statement. And that means that our equation here, number 5, matches with A. And by process of elimination, we're assuming that number 6 is going to match with C, but I just want to show you something with this equation first. When you're solving this, you get these icky looking fractions on the left. I'm going to show you something you can do that will clear those fractions. What we can do is we can multiply both sides of the equation by 5. We have to multiply everything by 5, but when we do that, we'll end up with just 12 here because these 5's would cancel out. And then 5 is going to be multiplied by this term, which means the 5's are going to be canceled out. And I'm just left with 12 minus x equals, on the right-hand side, I'll have 5x. And you do end up getting that boundary of x equals 2, which is where the dot is. Let's pick something, though, and test stuff out. So you could pick 0 because that's easy. So plug in 0 and see if it makes it true or not. Now, 0 is not in the solutions here, so we're actually hoping that it does not make our inequality true. When I plugged in 0, I ended up getting 12/5 is less than or equal to 0. That is not true because that's a positive number. So that's actually a good thing because 0 is not in our solutions here in C, which means that the arrow should be going to the right with the solution. So that does verify that 6 matches with C.